What occurs when mercury and aluminium cross paths? A fascinating question that leads us to an intriguing experiment. Firstly, let's set the stage with some facts. Mercury, a liquid metal, is known for its high density, low melting point, and high surface tension. You've likely encountered it in thermometers or barometers. It's also a champion at forming alloys with other metals, termed as amalgams. These amalgams find their way into various industries, from dentistry to medicine. On the opposite end, we have aluminium, a solid metal with low density and high strength. It's a common sight in construction, transportation, and packaging. While aluminium is quite reactive, it's typically protected by a thin layer of aluminium oxide, the barrier that forms when it meets air. Now, imagine combining these two metals, an exciting prospect, isn't it? The experiment itself requires aluminium foil, mercury, and a glass container. Remember, safety first. Gloves, goggles, and a mask are a must to protect from the toxicity of mercury. Begin by placing a small piece of aluminium foil in the glass container, followed by a few drops of mercury. At first, nothing seems to happen, the aluminium oxide layer acting as a shield between the mercury and aluminium. However, scratch the aluminium foil, breaking this oxide layer, and suddenly you expose fresh aluminium to the mercury. This allows the mercury to form an amalgam with the aluminium, disrupting the oxide layer further and leaving more aluminium exposed to the air. This triggers a rapid and intense reaction. The aluminium reacts with oxygen and water in the air, forming white aluminium hydroxide and releasing hydrogen gas. The reaction also generates significant heat, causing the mercury to vaporize and escape. The aluminium hydroxide grows into white fibers, similar to cotton candy or snow. The mercury amalgam darkens and crumbles as the mercury departs from the aluminium. Eventually, the reaction ceases when all the aluminium is consumed. What remains is a pile of white fibers and dark crumbs, the remnants of the mercury amalgam. This reaction is a vivid display of aluminium's reactivity, usually concealed by the oxide layer. It also showcases mercury's catalyst role, facilitating the electron transfer between aluminium and air. The reaction is exothermic, releasing vast amounts of energy in the form of heat and light. However, remember, this reaction is dangerous, producing toxic mercury vapor and flammable hydrogen gas. It demands proper safety precautions and disposal methods. Furthermore, it should be conducted away from any aluminium objects, as the mercury can cause severe damage. In conclusion, the reaction between mercury and aluminium offers a captivating glimpse into the world of chemistry. It highlights the hidden reactivity of aluminium and the catalytic role of mercury, while also reminding us of the importance of safety in scientific exploration. This concludes another episode of AI Science. If this piqued your interest, feel free to give it a thumbs up, share it with fellow science enthusiasts, and subscribe to the channel for more AI-powered scientific explorations.